Hi everyone, welcome back. In this session, we are going to discuss on how we can interpret the Black Scholes model as per the risk-neutral method. But before that, let us have a quick recap of what the risk-neutral method was under a single period binomial. The facts that we had in this case was, we had a strike price of 160, the spot price is 170, the risk-free rate is 7% per annum, and the standard deviation is 18% per annum, both of them compounded continuously. The time to maturity or the option contract period was for 6 months. And since we were following a single period binomial, we had only one time step and the length of the time step was 6 months. After that, we went on to calculate U, D, R and risk neutral probability. U was nothing but e power sigma square root of t, which is, let me just quickly write it down on the notepad as well for just to have a quick revision. So we had, we had U equal to e power sigma square root of t, which was equal to e power 0.18 into square root of 6 by 12. We had basically 6 months. So t was 6 by 12. Instead, I'm writing it as 0.5 years, right? Okay. And d was equal to 1 by u. 1 by u is nothing but actually 1 by e power sigma root t, which is nothing but e power minus sigma root t, right? I mean, it's just a different way of writing it, but the ultimate formula is d is equal to 1 by u, okay? When you solve this, you will get the value that we have over here, which is 1.136, okay? So u was equal to 1.136, d was equal to 0.88, and r was nothing but the periodic interest rate factor. R over here, basically the formula for r was e power rf into t, okay, which was e power 0.07 into again 6 by 12 or 0.5, which is e power 0.035, which we got it as 1.036. Okay, so r was 1.036, and then we calculated risk neutral probability. The formula for calculating risk neutral probability was r minus d divided by u minus d. When you solve for this, you get risk neutral probability as 0.608. Okay, and this is the risk neutral probability for the share price to go up. Okay, the risk neutral probability for the share price to come down is actually 0.392. Okay, it is nothing but 1 minus 0.608. So 0.392 for the share price to move down. Okay, but remember, in the original facts of the question, I did not give you the upside share price and the downside share price. We actually calculated the upside share price and the downside share price by multiplying S with U and D respectively. Okay, the upside share price was S into U. Okay, if I just write this one was S into U, and this is actually S into D. Okay, so if you actually see this 193 that we have over here is nothing but 170 into 1.136, and the downside share price that we have as 149 is nothing but 170 into 0.88. Okay, what we are essentially doing over here is we are saying that the share price at t equal to 6 can go up by 1 standard deviation or can fall down by 1 standard deviation. Okay, for instance, let me actually come back to the normal Excel file. See, the standard deviation for 1 year was 18% per annum, right? Okay, now if I ask you to find out standard deviation for 6 months, the answer is going to be 18% into square root of 6 by 12. Remember, I told you variance is proportional to time. Standard deviation is proportional to square root of time. Okay, so it's not going to be 18% into 6 by 12. It's going to be 18% into square root of 6 by 12, which is nothing but about 12.73%. Okay, 12.73% for 6 months. All right, the current share price is 170. All right, I am now telling you that you have to calculate the share price that will be at the end of 6th month. Okay, I'm asking you to project the share price at the end of 6th month, and we say that in binomial model that the share price can only take 2 possible values. So I'm now asking you to guess 2 possible values for the share price at the end of 6th month. Okay, what you're doing is you're saying that the one possible share price will be 1 standard deviation up, which is nothing but 170 into 1.1273. You're saying that in a span of 6 months, the share price can go up by 1 standard deviation or it can fall down by 1 standard deviation. Okay, 1 minus 0.1273. Okay, above I did 1 plus 0.1273. Here I did 1 minus 1.1273. Okay, binomial model is operating under a framework where it can have only two possible share prices at t equal to 6, and it is just guessing that the share price will be either 1 standard deviation up or 1 standard deviation down. Of course, the real world does not operate in this way, and therefore we know that binomial model is having several restrictive assumptions. Okay, we are aware of that. But this is also again one of the assumptions of binomial model, that the future share price will be 1 standard deviation up and 1 standard deviation down. Okay, let us actually calculate this. It is 191.64 on the upside, and on the bottom side it is 148.36. Okay, if you actually look at this, the answers are 191 and 148, and these are not matching with what we had over here. Okay, over here we have 193 and 149.68, and the reason they are not matching is because here I said 18% is per annum compounded continuously, whereas when I was actually showing you over here, I didn't take continuous compounding because I just wrote 1 plus r and 1 minus r. Okay, this is actually not continuous compounding, this is discrete compounding. Okay, whereas if you do the same thing on a continuous basis, if basically if you're saying that the share price can go 1 standard deviation up and 1 standard deviation down, but that is not on an effective basis or for 6 months, it's going to be done on a continuous basis for 6 months. Okay, like 18% is per annum compounded continuously, right? Okay, and when you do continuous compounding, the value that you're getting is basically higher. Okay, you're getting 193 instead of 191, and you're getting on the bottom side 149 instead of 148. Okay, so basically over here in the example that I wanted to show you, I just wanted to prove that the share price is being assumed to go 1 standard deviation up and 1 standard deviation down. Okay, but since the actual way of calculating u over here is e power sigma root t, what is happening is that standard deviation is getting compounded on a continuous basis. Okay, what we have done over here is we have multiplied s with u, where u is actually nothing but e power sigma root t, right? It is e power sigma square root of t. So the standard deviation is being compounded on a continuous basis to give us a share price of 193. Whereas for illustration, only to show you, I've just written it as 1 plus r instead of e power r. Okay, that's the only difference. Otherwise, the whole binomial model is working under the premise that the share price will change at t equal to 6. And in that, it is actually assuming that the share price can go either 1 standard deviation up or 1 standard deviation down. I agree this is an unrealistic assumption because the share price can move any which way it wants, right? Okay, the first unrealistic assumption is that the share price will only change at t equal to 6. The second unrealistic assumption is that we are saying that the share price can only take two possible values. The third unrealistic assumption is that we are saying that the two possible share values is going to be nothing but 1 standard deviation up from today's share price and 1 standard deviation down from today's share price. Okay, that is also a third unrealistic assumption because you can say it can go 2 standard deviations up and 2 standard deviations down, right? I mean, you don't have to really say just that it could go only 1 standard deviation up or 1 standard deviation down. Okay, so that is also a third unrealistic assumption. Okay, but that is basically a model that binomial model has taken. I mean, that is the model that the binomial model is using for predicting the future share price. Okay, to predict the future share price, you basically need to take an approach or a formula, and binomial model is basically using this approach. Okay, so this is what the risk neutral method was. Now, I will be showing you that Black Scholes within that formula, the formula that we have for call option and put option, is actually doing the same thing what binomial model under the risk neutral framework is doing, which is nothing but it is first predicting the future share price, just like how in a binomial model we predicted the future share price to be 193 and 149. Black Scholes also is predicting the future share price. After predicting the future share price, it is going to predict the future payoff. Just like in a binomial model, we predicted the future payoff to be either 33 or 0. Black Scholes is also going to predict the future payoff. Okay, in risk neutral, what we then did was we multiplied the payoff with the probability of P and 1 minus P to calculate an expected payoff, which was in between both the upper payoff and the downside payoff. Okay, and when we calculate the expected payoff, you get one number, which is nothing but the expected payoff from a call option. Black Scholes also is doing the same thing. It is multiplying the payoffs that it has got with the respective probabilities to calculate expected payoff at t equal to 6. And under the risk neutral framework, we then basically discounted this expected payoff into today's terms, and we called that as the value of the call option. The Black Scholes model also will do the same thing of discounting the expected payoff into today's terms, and that will be the value of a call option, because that is the standard DCF definition. The value of a call option today is the present value of the future cash flows that the call option is generating. Future cash flow is nothing but the expected payoff at t equal to 6. Okay, so the value of the call option today is the present value of the expected payoff. Okay, just like what we did in a risk neutral method, I will be showing you that Black Scholes is also doing the same thing. Okay, but we are going to have a problem. In binomial risk neutral method, I told you that the share price can take only two possible values. Okay. Whereas I told you that Black Scholes works like how the real world works. And in real world, at t equal to 6, you cannot say that you have only two possible share prices, because you're going to have infinite possible share prices, right? I mean, the share price can actually move from 170 to any number at t equal to 6. Agreed? So the first problem that we are going to encounter is how do we predict the share prices? Okay. And to predict the share prices, just like how binomial, I'll just erase all this. Yeah. So to predict share prices, binomial model use the formula of S into e power sigma root t and S into e power minus sigma root t. Okay. Binomial model had used this formula or used this approach to predict future share prices. Similarly, Black Scholes also is using a formula within within the model to predict the future share prices. Okay. It is using a formula. Okay. We'll see what that formula is later on. Okay. But like I said, firstly, let me actually draw a comparison between binomial and Black Scholes. Okay, let us say this is the binomial model. This is time to maturity and this is the price. Okay, let me denote it as S. This is the current share price, or the share price. Okay, this is time as t equal to 0. Okay, this is t equal to 0. Okay, and this is t equal to 6. Okay, the current share price is 170. Agreed? The current share price is 170 and I have a strike price of 160. Okay, this is the strike price. Okay, let me just extend this. Okay, this is t equal to 6. This is nothing but the expiry of the option. The current share price under binomial model, we are saying that it can take either 193 or it can take 149. Okay, either 193 or 149. Okay, this is what we were saying under the binomial model. This is nothing but S into e power sigma root t, and this is S into e power minus sigma root t. Agreed? Okay. So these were the two possible share prices under the binomial approach, where in this case, one share price was ending in the money and the other share price was ending out of the money. Okay, it is not necessary that the bottom share price should end out of the money. It can also be a case if you take the numbers or if you change the numbers in such a way, then the bottom share price could also be in the money. Okay, it is not necessary always that the bottom share price should be less than the strike price. Absolutely not. With the numbers that we have taken, we've got such an answer. Okay, there could also be a situation where the bottom side share price also is in the money. Okay, anyways, this is what the binomial model followed. Now let us draw a graph for Black Scholes. Okay, this is time. This is again share price. I have a current share price of 170 and I have a strike price of 160. Okay, I'm denoting this as E, exercise price. Okay, and you know that under Black Scholes, I told you that the share price can actually take any possible value. Okay, which means the share price, one such path could be that the share price actually reaches here. Okay, there could be another path where the share price can move this way, and at t equal to 6, it reaches this point. There could be another path where the share price increases, then decreases, and ends somewhere over here. The share price can also fall and end out of the money. Okay. The share price can also go this way and again end out of the money. The share price can fall below 160 and then rise and then end in the money. The share price can go up and then on the last few days it might fall and end out of the money. So basically, I know that the graph is clumsy, but what I'm trying to say is there are infinite possible paths for a share price. In a Black Scholes model, there are basically infinite possible paths. Okay, whereas if you actually observe over here, in a single period binomial, we have two possible paths. The share price can go either up or it can come down. In a single period, we had two paths. Okay, let me just write it down. In single period, we had two paths. In a two period binomial, we had four paths. If you remember, it was 2 square, right? We had four paths. In a 3 period binomial, we had 8 paths, which is 2 power 3. Okay, and that goes on. And now in Black Scholes, we actually have infinite possible paths, because like I told you, Black Scholes is nothing but binomial model split into infinitely small time steps, right? Now we have infinite possible paths, and we basically have to predict. I mean, the Black Scholes rather is predicting within its formula all those infinite possible paths, and it is assigning value to each particular path. It is estimating the share price at the end of each particular path. Okay, it is estimating the share price at the end of each particular path. It is calculating the payoff for each particular path. For instance, the payoff for each of these paths will be positive, and over here the payoff will actually be 0. Okay, and what the Black Scholes is doing is it is multiplying each path with the respective risk neutral probability. Okay, so each particular payoff is being multiplied with its probability, and then it's arriving at something called as expected payoff. Okay, it's arriving at something called as expected payoff at t equal to 6, and it is discounting this expected payoff into today's terms to arrive at the value of the call option at t equal to 0. Okay, this is basically being discounted to arrive at value of the call option today. Okay, so I'll just repeat what I said. What the Black Scholes is doing is it is calculating all the infinite possible paths which a share price can take from today to t equal to 6. Okay, a few of those paths are going to end in the money, which will generate positive payoff for a call option. A few of those paths are going to, going to ensure that the share price will be less than the strike price, which means the option will actually be out of the money. The payoff for such cases will actually be 0. It is finding the risk neutral probability for each particular path. Okay, and after finding the risk neutral probability for each particular path, it is multiplying the risk neutral probability with the payoff to arrive at something called as the expected payoff, and that expected payoff is at t equal to 6. It is discounting that expected payoff using the risk-free rate to arrive at the value of the call option today. The reason we are using the risk-free rate is because, again, the risk neutrality assumption comes into picture. Okay, just like how under a single period binomial framework, we assume that the person valuing the call option as a risk neutral investor within the risk neutral method. Okay, similarly, Black Scholes is also going to make the same assumption. Okay, and that is why the discount rate is going to be the risk-free rate. Okay, now the problem I will tell you is, or before that, let me just show you what we did under single period binomial also was exactly the same, right? We predicted the future share price, we calculated the payoff, if the share price was higher than the strike price, the option was in the money to generate a positive payoff. If the share price was less than the strike price, the option was out of the money and the payoff was 0. We then multiplied this payoff with the respective probabilities of P and 1 minus P. I know I'm repeating myself, but just to make that kind of complete, or I don't want you to have any doubts later on. Okay, so that is the reason I'm just repeating. We're multiplying with the respective probability to arrive at the expected payoff. This expected payoff is discounted into today's terms to find out the value of the call option, and the discounting was being done at a risk-free rate because we assumed the investor to be a risk-neutral investor. Okay, now compare this exactly with the Black Scholes model, and you will realize that what Black Scholes and risk-neutral method are doing is one and the same. Okay, now I would like to make one statement. Okay, to basically predict the share prices, just like how in a risk neutral method, the share price was predicted as S into e power sigma root T and S into e power minus sigma root T, Black Scholes is also going to use a formula for predicting the share price. Okay, you can theoretically stand at T equal to 0 if I ask you, and if I tell you that the share price today is 170, what could be the possible share price at T equal to 6? Okay, you will come and tell me that at T equal to 6, the share can go as high as up to infinity and it can touch a bottom of 0. Okay, if I ask you, your prediction will be it can be anywhere between 0 to infinity. Okay, this will be your prediction. Agreed? Okay, but the Black Scholes is not going to use human emotions to predict the share price. Okay, the Black Scholes is going to use a formula to predict the share price, and that formula is going to be dependent on risk-free rate of 7% and standard deviation of 18%. Okay, when we are saying that the share price has a standard deviation, or the returns have a standard deviation of 18%, okay, a share price cannot go from 170 to infinity, or a share price cannot fall from 170 to 0. Reason being, if a share price falls from 170 to 0, its standard deviation is going to be massive. Okay, because I mean, it's 100% return fall, right? Okay, so the standard deviation of returns will be huge. Okay, so you have given a constraint of 18% standard deviation, which means the share price can only move in a certain path, right? Okay, you will have an upper and lower bound of share price. When you've given an input of 18% of standard deviation and a return of 7%, you're obviously saying that the share price is going to have a range. Okay, the share price will be moving only within that range. In real world, the share price can break that range in exceptional circumstances. Okay, but in general, the share price will be moving in a particular range. Okay, by T equal to 6. But in exceptional circumstances, if there are extremely abnormal events that occur, the share price may actually go above that the upper limit, and it can fall below that lower limit. Okay, let me just give me a second. I'll just erase this and give me a second. Okay, so what I was basically saying was, we have given two constraints. One, that the risk-free rate will be 7% or the return will be 7%, and two, the standard deviation is 18% per annum. Okay, when we have given them these constraints, of course, theoretically, you will still say that the share price can go up to infinity or it can come crashing to 0. But the Black Scholes model is going to say that the share price can take an upper limit of this one and a lower limit of so-and-so price. For instance, we have the current share price of 170. Okay, we have a current share price of 170. The Black Scholes is going to say that the share price can maximum move to 290 on the upside, and it can maximum move to 105 on the downside. I will tell you how I calculated these values. Give me a minute. Okay, but the Black Scholes model is going to say the share price can be moved to any value in this particular range. Okay, and the reason these values have come up is because we have given constraints that the share price has a return of 4%, and the standard deviation of all those returns is actually 18% per annum. Okay, given these constraints, the Black Scholes is calculating the upper limit and the lower limit. Okay, in real world, by the end of T equal to 6, if there are abnormal events, the share price can or may end up above 290, or it may end up below 105. I'm not saying no, okay? But that is an abnormal situation, and the Black Scholes model will not hold good in such cases, okay? The Black Scholes model is going to hold good in normal circumstances, and where under normal circumstances, Black Scholes is going to say that the share price can touch a maximum of 290 and it can touch a minimum of 105, and within this particular range, there are going to be infinite possible paths that a share price can take. Remember, within this, there will be, the share price does not have to move only in whole numbers, right? The share price can also move in decimals. Okay, so within this particular range, a share price can probably take 170.05, 170.06, 170.07, 170.08. So between 290 and 105 also, there are going to be infinite possible paths. Okay, please do not be of the misunderstanding that 290 minus 105 is only about 185. So there can be only 185 possible share prices. The answer is no. There can be infinite possible paths and infinite possible share prices within this range. Okay, paths and also share prices. If you remember, share prices and paths are two different things. Paths are basically how a share price moves to end at one particular share price, right? For instance, in a single period binomial, let's say in a 2-period binomial, if you remember, let me bring it up on screen. In a 2-period binomial, we have 3 possible share prices, but we actually have 4 possible paths. Okay, so the number of paths and the number of share prices are actually different. Okay, so over here, within the Black Scholes model, what the Black Scholes is doing is it is calculating an upper range and an upper limit and a lower limit. And within the upper limit and lower limit, the Black Scholes model is calculating all the infinite possible share prices, and it is calculating the expected payoff that will be the call option will generate from those infinite possible share prices. It is multiplying each of that payoff with the risk neutral probability to arrive at the expected payoff, and that expected payoff is being discounted to today's terms at the risk-free rate. Okay, that is what the Black Scholes model is actually doing. Now, how am I actually going to show you that the Black Scholes is doing this? Okay, it is easy for me to say that the Black Scholes is actually basically calculating. Okay, so basically in this graph, apologies, I'm just making one change. In this graph, I am saying that the Black Scholes has an upper limit of 290 and a lower limit of 105, and it has infinite possible paths within this upper limit and lower limit. Anyways, now how am I going to show you how the Black Scholes is actually doing this within its formula? Okay, what I will be doing is, I obviously cannot show you all the infinite possible paths or the infinite possible share prices that the Black Scholes is calculating. Okay, so what I will be doing is, I will take 10,000 out of these infinite possible paths. Okay, let us say, I mean, it's a little difficult when I keep saying infinite possible paths, infinite possible paths. Let us assume that there are 10 lakh possible paths. Okay, hypothetically, there are 10 lakh possible paths. Okay, out of these 10 lakh paths, I will be taking 10,000 possible paths. Okay, 10,000 possible paths, which give me some share price at the end of t equal to 6. And remember, each path, I mean, 2 different paths can lead to the same share price. Okay, 2 different paths can lead to the same share price. For instance, in the 2-period binomial, we had 2 paths which led to the same share price, right? Similarly, when I'm taking 10,000 paths, I can still have the same share price at t equal to 6. Okay, I'm just randomly taking 10,000 possible paths out of an assumed number of 10 lakhs. Okay, actually this 10 lakhs is infinite paths, but since I cannot keep saying infinite, I'm just saying, let's say that there are 10 lakh possible paths between 105 and 290. Okay, out of these 10 lakh paths, I am taking a sample of 10,000 possible paths, which means I'm taking a sample of 1%. Okay, I'm just taking a sample of 1%, leaving the whole rest 99%. Okay, now I will be taking 10 possible paths on the Excel file, and I will show you that. So at 10 possible paths, we will have 10,000 share prices, and there could be repetitions. Okay, I'm not denying that there will be no repetitions. There could be repetitions, could have repetitions, because like we said, two possible paths can lead to the same particular share price, right? So there could be repetitions. Okay, now, so we have, let's say 10,000 possible share prices. Okay, I will be calculating the payoff of the option for each particular share price. And over here, I was saying if this is the share price, there could be some repetitions in this. Out of this, there will be some payoff that I will be calculating. Okay, that payoff, I will multiply it with the risk neutral probability. And I will show you that the present value of that expected payoff is going to be equal to the value that the Black Scholes model gave us. Okay, but there will be a marginal difference. Reason being, I am only taking 10,000 paths out of total infinite paths, right? I'm working on a sample of 1%. Okay, and the reason I'm forced to take sample is because my Excel will crash if I take anything more than that. Okay, that is the reason I'm only picking 10,000 possible paths out of all the infinite possible paths that are there, right? Okay, and the value that we get on the Excel file is going to have a slight difference when we compare it to the value as per the Black Scholes model. Reason being, I have worked on a sample. Had I taken all the possible paths, then my answer would have been exactly the same as Black Scholes. Okay, but it is not possible for me to show it to you, and hence we are going to work on a sample basis. Okay, even if you have not understood, I think it's fine. We will slowly just get there. Okay, just follow it. Okay. So this is basically interpreting the Black Scholes model as per the risk neutral method. And the steps are going to be: one, we have to calculate or project the future possible share prices, because unlike binomial model where we said that the share price can only take two possible values, over here, the Black Scholes can take infinite possible share price values, right? Okay, because that is how the real world works as well, correct? Okay, so we have to project the infinite possible share prices, which is standing at t equal to 6. Okay, in the binomial model also, we use the formula to project the share prices, which was nothing but s into e power sigma root t and s into e power minus sigma root t. Whereas in Black Scholes also, we will be using a particular formula, which is not s into e power sigma root t or s into e power minus sigma root t. We will be using a formula which will take into consideration the fact that the volatility is 18% and the risk-free rate of return is 7%. Okay, it is going to calculate the future possible share prices given these constraints. If you keep changing these constraints, of course the future possible share price will keep changing. Okay, next, the step 2 is we have to calculate the risk neutral probability for each particular share price. Okay, at t equal to 6, of course. Okay, the second step is calculating the risk neutral probability. The third step is we calculate the expected payoff of the option contract at maturity. And finally, we calculate the present value of the expected payoff, which will be nothing but the value of the call option. We calculate the present value at the risk-free rate using the risk-free rate, because we are assuming risk neutral investor. Okay, so this is the process of calculating, or this is what actually the Black Scholes model is doing within that formula. And I will be showing you 10,000 possible scenarios on an Excel file. Okay, first, coming to modeling stock prices. Here, I would like to introduce one of the assumptions that the Black Scholes makes. It assumes that the stock price follows something called as geometric Brownian motion. Okay, Brownian motion is actually a concept of physics which talks about how molecules or particles move in a random fashion. If you remember your 8th or 9th class physics, you used to read about molecules. Okay, there is something called as Brownian motion in physics, which says that molecules move in a random fashion. Okay, the Black Scholes model assumes that share price also, like molecules, move in a random fashion, and that is the reason we are saying that the stock price follows geometric Brownian motion. Okay, so Black Scholes has basically borrowed a concept of physics and has applied it to this. Okay, the most important thing is the share price moves in a random fashion. The share price moves randomly. Okay, that is the most important thing. This is all I know about Brownian motion. I do not know anything more about Brownian motion other than this. Okay, but this is sufficient. Okay, the next thing it says is the stock prices, they fit into a distribution called as log normal distribution. I'm sure CFA students and FRM students might have heard the word log normal distribution. So my address is more to CA final students. Whenever I utter the word distribution, what should come to your mind is there is a set of data and there is some probability against some data, or there is some frequency against some data. Okay, and that whole data set is going to be called as a distribution. Okay, there is some data set which has some frequency or probability against it, and the whole data set is going to be called as distribution. Okay, so we are saying that the stock price follows log normal distribution. We will see what the implication of log normal distribution is in the next slide. Okay, the binomial model, unlike Black Scholes, assume that the share price actually follows binomial distribution. Okay, so binomial model assume that the share price follows binomial distribution, and the binomial model, basically we said that the share price can go one standard deviation up and one standard deviation down, right? Okay, that formula is nothing but coming from binomial distribution, because it assumed that the stock prices follow binomial distribution. So to project that future share price, it used the binomial distribution, whereas the Black Scholes is using log normal distribution to project the future share price. Okay, so what we are going to do is we are going to run 10,000 simulation to project the future possible share prices that this stock can take on the maturity of option contract. But remember, theoretically, although you can say that the share price can touch infinity or zero, Black Scholes is not going to allow you to do that. It is going to have an upper share price and a lower limit for share price. And within these limits, it is going to project all those infinite possible paths. The reason it has an upper limit and a lower limit is because we have given it a constraint of having a return of 7% and a standard deviation of 18%. Okay, so with these constraints, you're going to have an upper limit and a lower limit. All right. But remember, one key thing is we are still assuming ourselves to be a risk neutral investor. Okay, and the risk neutral investor's expected rate of return is actually the risk free rate. Okay, a risk neutral investor wants a risk free rate of return from any particular asset, be it a stock or an option. Okay, so if we are saying that the required rate of return for a risk neutral investor is actually the risk free rate, the expected share price will be S0 into e power RT, right? Because today the share price is S0, the expected return on share is RF. So of course the expected share price at t equal to 6 has to be S0 into e power RT, right? But this is expected, okay? So we are calculating 10,000 possible paths. Each path is going to have some probability. The expected share price should actually be equal to S0 into e power RT. Remember that, okay? The expected share price should be equal to S0 into e power RT, because we have assumed ourselves to be a risk neutral investor. The required rate of return for a risk neutral investor is the risk free rate. If the share price is S0 today, the expected share price has to be S0 into e power RT, because that is what the risk neutral investor expects. Okay, but that is an expected share price. Okay, expectation means average. Okay, so the 10,000 simulations that I'm going to run, the average of all those share prices, with each share price being multiplied with its respective probability, has to be S0 into e power RT. Okay, I'll show you how it is going to be that. Okay, next is, what is simulation? Simulation basically involves picking random draws of all the future estimated share prices or the estimated paths that a share price can take by t equal to 6, because the share price can actually take infinite possible values within a particular range. I am going to choose 10,000 out of all those infinite possible paths on a random basis, and this process is actually called as simulation. Okay, and the second paragraph is basically dealing with why Black Scholes model cannot be used for American options. I will come back to this paragraph after showing you how we model stock prices, or after showing you how the present value of the expected payoff is calculated. Okay. Let me come to my Excel file. Here, there is going to be some trouble. This is the formula that the Black Scholes is using for calculating the expected share price. It's saying that the expected share price at t equal to 6 is equal to the current share price, which is S multiplied by exponential of RF minus 0.5 into sigma square. I said exponential of RF minus 0.5 into sigma square, the whole into T plus sigma into Z into square root of T. Okay, the exponential is basically applied to the whole term. Okay, for instance, the exponential, let me just, exponential is actually applicable to the whole highlighted portion. Okay, after you calculate the whole highlighted portion, you apply exponential to that. Okay, so the formula is ST is equal to, or the future share price is equal to S into exponential of RF minus 0.5 into sigma square, the whole into T, plus sigma into Z into square root of T. Okay, this RF minus 0.5 into sigma square into T, do you remember seeing it anywhere by chance? Take a guess, take some time and try to guess. It was a part of D2 formula. Okay, if you remember, the formula for D2 was ln of S by E plus RF minus sigma square by 2 into T. Okay, this particular part, which was actually a part of D2, is actually being used to predict the future possible share prices. Okay, and we then have the latter term, which is sigma into Z into square root of T. Okay, it is basically sigma into root T into Z. Okay, that is what we have. Okay, and you know that sigma into root T is also being used by Black Scholes at multiple places. Okay, but now I actually told you that the share price can take infinite possible paths within a particular range. Okay, I have given you one particular formula, and one particular formula can lead only to one particular share price, right? I mean, if I give you one formula and if you input everything on the RHS, the LHS will only be one. Okay, I mean, you can have only one LHS, right? One answer for one set of inputs. But I am telling you that the share price can actually take infinite possible paths. How am I going to find out those infinite possible paths? The answer is I will be changing Z every time. And Z is nothing but the standard normal distribution that you actually read. Okay, let me bring out the standard normal distribution table. Okay, so this is the standard normal distribution. If you see over here, Z value can be minus 3.9, it can be minus 3.8, minus 3.7, and so on. And it has second decimal also. Okay, so it can be minus 3.9 or minus 3.91, minus 3.92, minus 3.93, etc., etc. And the final value is minus 3.99. Okay, and similarly on the bottom side also it can have plus 3.99. Okay, so what we will be doing, or what this formula is basically going to do, is it is going to keep changing the value of Z every time to calculate the possible share price at t equal to 6. Everything else is actually a constant. If you see, RF is constant of 7%, sigma is constant at 18%, t is going to be constant at 0.5, sigma again is 0.18, and square root of t is 0.5. Okay, I said t is constant because we are standing at today and predicting the future share price. Okay, of course the time to maturity is going to reduce, I'm not denying that, but what I'm saying is by constant I mean we are standing today and we are predicting the share price at t equal to 6, and every time we predict, the remaining time is still going to be 6 months or 0.5 years. Okay, so in that way I meant t is constant. Okay, the only thing that we will keep changing is actually Z. Okay, what this formula is going to do is each time it's going to pick up a value of Z and it is going to calculate the future possible share price. Now your question will be, sir, we have only limited number of Z values from minus 3.99 to plus 3.99, right? So the number of Z values are not unlimited. But my dear friends, here we have only up to 2 decimals, but the Z value can also go beyond 2 decimals, right? You can have a Z value of minus 1.73457, whatever. Okay, nobody is denying that. Okay, but for standard normal distribution tables, for printing it on paper, we only look at up to 2 decimals. But in reality, you can still have any number of Z values, right? Okay, so what this formula is basically going to do is it's going to calculate a random value for Z each time, and it is going to calculate the future possible share price. And what the Black Scholes is doing is it is taking all the possible values of Z and it is calculating the future possible share price. Okay, for instance, and remember I told you that I gave you an upper limit of 290 and 105. the way I gave you that upper limit is by substituting Z as 3.99 and minus 3.99. Okay. Actually, if you ask me, the value of Z can go beyond minus 3.99 also, but the probability is actually already in the fourth decimal, or it's actually in the fifth decimal, right? Okay. So value beyond minus 3.99 is going to have probability somewhere in the corner. Okay. So there is a chance for the share price to go above that range, but the probability is going to be very, 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 very minuscule. Okay. So I calculated the upper share price by substituting Z as plus 3.99, and I calculated the lower share price by substituting Z as minus 3.99. Okay. Let us quickly just see what we are going to get. I'm applying this formula. I hope you're able to see the screen. Otherwise, I'll just zoom it a little. Okay, I'm applying the above formula. It is S, which is 170, into exponential of RF, which is 0.07, minus 0.5 into sigma square, which is 0.18, the whole square. Okay, I'm closing the bracket over here, into 0.5, which is T. Okay, and then I have plus sigma, which is again 0.18, into 3.99 into square root of 0.5. Okay, I'm just, the answer is 290. Okay, and when I, let's say I copy the same formula and I substitute minus 3.99, the answer I get is 105. Okay, of course Z value can be above 3.99, it can also be less than minus 3.99, but the probability is lying in some extreme corner. At 3.99 itself, if you saw, the probability is lying in the fifth decimal. Okay, so imagine what the probability will be beyond 3.99. Okay, so that is the reason I've put an upper limit of 290 and 105. And what I have basically done is I have calculated 10,000 possible share prices. I've calculated 10,000 possible share prices by changing the value of Z. Okay, am I stupid to actually keep changing the value of Z each time? Obviously no, right? I won't be taking all those infinite possible Z values, right? So what I've done is I have basically inserted this formula of norm S inverse bracket random. Okay, so what equal to rand function does is it basically gives you a number between 0 and 1. On a random basis, it gives you a number between 0 and 1. Okay, and what lies between 0 and 1 is actually probability, right? Okay, on the function equal to rand gives you a number between 0 and 1 on a random basis, and what lies between 0 and 1 is actually probability. And then I have applied a formula which basically converts probability into Z value. Okay, I have, now that I have a probability, it converts probability into Z value, and that function is nothing but norm S inverse. Okay, given a value of given a probability of 0.65, the Z value is actually 0.4. Okay, that is how you actually have to interpret. Okay, so every time basically when I keep pressing refresh, the random number changes. Okay, which means the probability is changing, and every time the probability is actually changing, I have my Z value changing. Okay, so every time I press refresh, the random number changes, which means the probability is changing, and with the change in probability, the Z value is also changing. Okay, so I have basically inserted that function over here, and I ran that 10,000 times. Okay, and each of the time, the random number that is going to come inside, the random number that is going to get generated inside is going to be different, which will by itself ensure that the Z value is going to be different for me. Okay, so I have basically inserted this formula 10,000 times, and the inside this random number is different every time, as a result of which Z value is different every time. Okay, so I calculated 10,000 possible paths. Okay, for 10,000 possible paths, I then calculated the payoff. I calculated the payoff. See, each time I actually keep pressing refresh, if you see the first path, the second path, and the third path, they will actually keep changing, because the random number inside them is changing. Okay, so all the 10,000 possible paths are actually getting refreshed whenever I keep pressing the number F9. Okay, F9 is for refresh in Excel, right? Okay, and then I'm calculating the expected payoff. The expected payoff is nothing but either 0 or positive. Okay, if the share price is greater than 160, I have an expected payoff of 29 in the first possible path. If the share price is less than 160, I have a payoff of 0. Okay, and then accordingly, I also put whether the option is getting exercised or lapsed. If the option is getting exercised, I have put a number 1. If the option is getting lapsed, I've put a number 0. Okay, I hope you're following it. If the share price is greater than 160, I will have 1 over here because the option is getting exercised. If the share price is less than 160, I will have 0 over here because the option is getting lapsed. Okay, this is for a call option, obviously. Okay, so I have the possible share price, I have the possible payoff at maturity, but now I have to calculate the risk neutral probability. Okay, because if you remember, our second step was actually calculating the risk neutral probability, and then we have to multiply the risk neutral probability with the expected payoff. Okay, so coming to calculating risk neutral probability. So the first proposition is, as the number of steps in a binomial model increase and tend to infinity, the probability of up move and down move in each time step tend towards 0.5. Okay, if you actually remember, in a single period binomial, let me just bring up the single period binomial on the screen. We had a probability of up move of 0.6 and a probability of down move of about 0.4, right? When we moved from one period to two period binomial, the probability of up move actually decreased from 0.6 to 0.58, and the probability of down move has increased from 0.4 to 0.42. And what we are saying is, as the number of time steps in a binomial start to increase and tend towards infinity, the probability of up move and the probability of down move will actually converge to 0.5. Okay, so I have basically prepared an Excel sheet where we can calculate the risk neutral probability for the, where we can actually see the risk neutral probability as the number of time steps increase. The facts are the same as what we have been following. These are the number of time steps. Okay, in case of 1 time step, 2 time steps, 10 time steps, and then so on till 1 lakh time steps. All right, each time step is basically nothing but the contract of the option period divided by number of time steps. In case you have 2 time step, each time step length is 0.25 years. Agreed? And then I calculated u as nothing but e power sigma into square root of t, where square root of t is actually the length of time step and not the option contract period. Okay, option contract period may be 0.5 years, but the length of each time step is only 0.05 in case of 10 time steps, right? So e power sigma root t is, in e power sigma root t, t refers to the length of each time step. Similarly, I've calculated d as 1 by u, and then I calculated r as e power rt, but again t over here is actually nothing but the length of each time step and not the length of the option contract. Okay, so I calculated u, d, and r. Now the probability of up move is easy to calculate. It's nothing but r minus d divided by u minus d. Okay, and I've calculated the probability of up move. If you see, for 1 time step, which means a single period binomial, the probability of up move is 0.6. For a 2 period binomial, the probability of up move is 0.5755. For a 10 period, it becomes 0.53. And as the number of time steps actually increase, in a 10,000 period binomial, the probability of up move is 0.5. Okay, obviously if the probability of up move is 0.5, the probability of down move is also 0.5. Okay, in a 1 lakh period binomial, it becomes much more less. It's much more closer to 0.5. Okay, so probability of down move is nothing but 1 minus probability of up move. Okay, so I've basically shown you with formula that as the number of time steps increase, the probability or risk neutral probability of both up move and down move, they converge to 0.5. The probability of up move in this case started falling to reach 0.5, and the probability of down move started increasing because the probability of down move in the first case was 0.4. So 0.4 kept on increasing to 0.5. Okay, so both of them converge to 0.5. Now what is the implication of it? I'll tell you. So let us take a case of two-period binomial. You have this as the current share price. The share price can go up either to this value or to this value. And this is at t equal to 3 because you have a two-period binomial. This is at t equal to 3. At t equal to 6, it can either take this or this or this or this. Agreed? This is at t equal to 6. Okay. Now imagine that the probability of up move is 0.5. The probability of down move is also 0.5. Agreed? Now if you actually see, okay, the probability for a share price to move from here to here is going to be 0.5 into 0.5, which is nothing but the joint probability, or 0.25. Okay, so the probability for a share to move from the current share price to the uppermost node at t equal to 6 is actually 0.5 into 0.5, because it has to rise twice, right? It has to increase the first time and it has to increase the second time also. So the joint probability is 0.5 into 0.5, which is 0.25. Similarly, the probability that the share price will reach the downmost node in the at t equal to 6 is again going to be 0.5, because the share price has to fall twice. It has to fall once, the probability of which is 0.5, and it has to fall the second time also, the probability of which is 0.5. And therefore, the downmost move probability is also going to be 0.25. Okay. And if you actually see, the probability of reaching this particular share price is going to be, remember there are two paths to reach this share price. Okay. So firstly, there are two paths, and the probability of each path is going to be 0.5 into 0.5. Okay. Because it has to first rise and then decrease, or first decrease and then rise. The probability of each of which is 0.5. Okay. So 2 into 0.5 into 0.5, which will be 0.5. Okay. If you actually see, there are four particular paths, and sum total of all probability is obviously 1, right? Four particular paths. Each path has a probability of 0.25. If you see, the upper path has a probability of 0.25, the down path has a probability of 0.25. This share price has a probability of 0.5, but within that share price, there are two paths, each of which has a probability of 0.25. Okay, so the implication is when P becomes 0.5, the the probability for reaching one share price is going to be 1 divided by the number of paths. See, this is P equal to 0.5 is upside move probability. Okay. But this probability that I'm talking about is the probability to reach a particular share price, or the probability of each particular path rather. So if the risk neutral probability is 0.5, which means if the upside move and the downside move are equal to 0.5, then the probability of each particular path, okay, becomes 1 divided by number of paths, which in this case is 1 divided by 4, which equals to 0.25. Okay, each path is going to have an equal chance of occurring. Okay, of course, the share price has a probability of 0.5. Reason being, there are two particular paths which converge to the same share price. Okay, the probability of each particular path is actually 1 divided by the number of paths, which is 0.25. And in that case, basically, I don't have to take weighted average, because if the weights are equal, I don't have to take weighted average. I can just take a simple average. Okay, because if all the paths have the same probability, then why do I have to apply weights? I can just do a summation divided by n, right? I mean, that is what we are doing over here, right? We are dividing it by number of paths. Okay, so I don't have to do weighted average anymore. It is okay if I start doing simple average. Okay, so as the number of paths tend to infinity, the probability of up move and down move become 0.5. And when the probability of up move and down move become 0.5, the probability of each path becomes equal. Okay, and we saw that. Okay, the probability of upper path is 0.25, the probability of down path is 0.25, the probability of this path is 0.25, and the probability of this path is also 0.25. Okay, so it becomes basically, I mean, you can stop using weighted average and start using simple average. Okay, and in Black Scholes, we actually have infinite possible values. So we basically don't use weighted average anymore. We start using simple average, which means in the Excel file that I have, I had these many payoffs, right? These were the payoff of the call option at t equal to 6. I don't have to multiply this with the risk neutral probability anymore. I can just take a simple average of it. Okay, and if I just take a simple average, remember, and so I've just applied the Excel formula of average. I have a value or expected payoff from a call option of 18.7. This is the expected payoff, remember, okay? Because expected payoff is nothing but in a single period binomial, expected payoff was future payoff multiplied by the probability. But where the probability is 0.5, I don't have to multiply the future payoff by the number of by probability. If I just take a simple average, it will be fine. It will be sufficient. So I've just taken simple average to calculate the expected payoff. Okay. If you just keep observing, every time I press F9, the expected payoff will actually keep changing. Okay. So, and then I have expected payoff at t equal to 6. If I discount it to today, what I will get is the value of the call option. Okay, so this is the expected payoff at t equal to 6. I am discounting it or to today's terms using e power rt, and I'm getting a value of 18.22. And if you remember that Black Scholes gave an answer of 18.20, it was 18.199. Okay, this one is giving me an answer of 18.22. Reason being, I'm working with 10,000 possible paths out of infinite values. Okay, there could be infinite possible paths, and I'm taking only 10,000 of them on a random basis. Okay, so I've not considered the whole population, and of course I'm going to have a marginal difference. Okay, and if I keep actually pressing F9, this value will keep changing. Okay, it's going to hover around the same 17.918 value, but I mean, it's going to change, it's going to deviate around that 18.2 value in such a way that the deviations actually offset, and on an average, it's going to be 18.2. What I mean is, when I keep pressing F9, sometimes the value is less than what the Black Scholes gave us. Sometimes the value is more than what the Black Scholes gave us. Okay, so basically there's some deviation both on the positive side and on the negative side, but the deviations tend to offset each other. Okay, so if I keep pressing, see, once it was 18.46, now it's 18.12, 18.21, 18.38. Okay, so it will keep changing because the random number inside this is actually changing, which is causing the option value to change. Okay, if the Black Scholes, but in its formula, is actually taking all the possible Z values and it's calculating all the possible share prices, and then it's calculating the payoff, discounting that payoff by using simple average and risk-free discount rate. The reason it is using simple average is because as the number of time steps tend to infinity, the probability of up move and down move become 0.5, which means each possible path has an equal chance of occurring. And when it has an equal chance of occurring, there is no point in taking a weighted average. You can just take a simple average and move on. Okay, so that way I have shown you what the Black Scholes is doing, but I have shown you with a sample of 10,000 share prices, whereas Black Scholes is actually considering all the possible share prices. Okay, there are a few other things that I want to show. Unfortunately, the lecture is not over. I know it's getting a little lengthy, but it's fine. Okay, the first thing that I want to show you is, I told you that the expected share price should actually be S0 into e power RT. The expected share price should be S0 into e power RT. Okay, let's take the expected share price. And now I'm taking simple average again. Reason being, the probability of each possible share price is actually the same. Okay, when it is the same, I will actually take the same, I will take a simple average, right? I won't take a weighted average. Okay, the expected share price is 176.2362. And this, I said, should be equal to S0 into e power RT. Let us calculate S0 into e power RT. S0 is 170 into e power R into T. It is 176. Okay, if you remember, this is also again going to change, but see, it's going to have a slight deviation. 175.78, 176.06. Now it is almost equal, 176.06 and 176.05. And now sometimes it might be much higher than 176.05 also. See, for instance, you are getting 176.18. So sometimes the average share price that I'm getting through these 10,000 prices is going to be more than what it should be. Sometimes it's going to be less than what it should be. And that is because I'm working with a sample of 10,000 prices. Okay. So I've also shown you that the expected share price of all these possible values is actually S0 into e power RT. Okay. That is done. Now there's something else that I also want to show you. If you see, I had a coding of 1 or 0 based on exercise or lapse. Okay. And I have taken an average of it. I've taken a simple average of it. And what this average actually means is, if I have projected 10,000 share prices, okay, 0.76 out of one time, the share has got the call option has got exercised. Okay. And 0.24, the call option has got lapsed. Okay. Which means out of 10,000 possible times, 7,600 times the call option has got exercised. 2,400 of the times the call option got lapsed. Okay. So this is basically nothing but for every one time, I mean, on a random basis, if I pick a possible share price, there is a 0.76 chance that a call option will get exercised. I will repeat myself again. On a random basis, if I start picking the share price at t equal to 6, there is a 0.76 chance or 76% chance that the call option will get exercised at that particular share price. Okay. Don't you think that this is actually the probability that a call will get exercised, right? Because I'm saying that out of 10,000 times, 7,600 times the call got exercised. Okay. So basically out of 100 times, 76%, 76 times the call option is got exercised, right? So 0.76 out of 1, the call option is getting exercised, which means 0.76 is actually the probability that a call option is going to get exercised. And probability that a call option is going to get exercised was nothing but, if you remember, it was ND2. ND2 was the probability that a call option will get exercised. And if we come back to our sum where we actually solved the Black Scholes formula, here you have ND2, it was 0.7540. We got 0.7607, which is slightly higher. And again, the reason is because we are working with 10,000 share prices. If I keep pressing refresh, sometimes the value will be less than 0.75 also, and sometimes the value will be more than 0.75. See, for instance, now at 0.7490, 7488, it's going to hover around that value, okay? But on an average, it is 0.75, which is equal to nothing but ND2. ND2 is nothing but the probability that the call option will be exercised, which I've actually shown using the numbers, okay? So ND2 is nothing but the probability that the call option will get exercised, okay? I've shown this as well now. Now, let me quickly, I'm just seeing if there's anything left. Okay, fine. So we saw what risk neutral probability is. Now let me come to the implication of log normal distribution. Or before the implication of log normal distribution, let us complete actually this paragraph. Okay. If you remember, American options can be exercised in between also. Okay. Whereas European options cannot be exercised in between. What Black Scholes is doing is, it is calculating the share price at t equal to 6 and then calculating the expected payoff at t equal to 6. Okay. Although it's looking at all the infinite possible paths, it is being kind of, blindfolded towards what the share price is going to be in between. It is only concerned with what the share price is going to be at t equal to 6. Okay. The Black Scholes model is being blindfolded to what the share price is going to be in between 0 and 6. And it is only looking at the possible share price at t equal to 6. Whereas for an American option, what the share price is going to be in between also matters. Okay. The share price in between matters because you have the right to exercise in between. Agreed? Okay. Whereas Black Scholes is actually ignoring that. Okay. It is taking all the infinite possible paths, but it is directly jumping to the share price that will prevail at t equal to 6. Agreed? It is not looking at what the share price will be tomorrow, day after, the day after, and so on. Right? Okay, that is the reason American options cannot be used for, Black Scholes model cannot be used for valuing American options, because American options, you will actually have to look at the share price that is going to prevail on each day. Okay, and that is the reason for American options you can only use a binomial model, and in binomial you start by constructing trees. Okay, and of course when you construct trees you're going to make those unrealistic assumptions, and that is the reason you have to choose a sufficiently long binomial period, meaning the number of time steps has to be at least 20 or more. Okay, for you to actually have a good binomial model, the number of time steps should be at least 20 or more. Of course, you're not going to do it with pen and paper. You're going to do it with a calculator only, but you should ensure that the binomial model for American options has to have minimum 20 steps or more in real world, in practical world. ICA is not, or ICA or CFA Institute or GARP is not going to ask you a 20 period binomial for sure. Okay. Anyways, so that is the reason American options cannot be, you cannot apply Black Scholes for American options. Okay. We're calculating the payoff at maturity and discounting without giving any consideration to the fact that there could be an early exercise also. And early exercise is going to depend on the share price prevailing on that day, right? Okay. So that is with regard to why Black Scholes cannot be used for American options. Now this is with regard to the implication of log normal distribution. Okay. So the first thing is, when any variable x follows log normal distribution, when any variable x follows log normal distribution, the meaning of it is x is going to be, one implication of it is x is going to be greater than or equal to 0. Okay, a log normal distribution does not allow the variable x to take negative values. Okay, and Black Scholes model assumes that stock prices follow log normal distribution, which means stock prices cannot have a negative value, which also holds true in real world, right? Stock prices cannot have negative value. So it is actually correct to assume that stock prices follow log normal distribution. Agreed? Okay, this is the first implication. The second implication is, when x follows log normal distribution, ln of x, natural logarithm of x, follows normal distribution. Ln of x follows normal distribution. Agreed? One second, guys. Okay. Now, what does ln of x mean? Okay. Before that, if ln of x follows normal distribution, it also means that ln of x, let me say xt refers to let me say x small t, where xt refers to the share price today. Okay. Ln of share price today minus ln of xt minus 1 follows normal distribution. Okay, because if addition or deletion or addition or subtraction of two or more normally distributed variables will also follow normal distribution. Okay, so ln of xt minus ln of xt minus 1 follows normal distribution. And if you remember, ln of a minus b, ln of a minus ln of b is actually equal to ln of a by b. Okay, using this property, now I'm rewriting this as ln of xt divided by xt minus 1 follows normal distribution. Okay, ln of xt by xt minus 1 follows normal distribution. Ln of xt by xt minus 1 is nothing but continuously compounded returns of share. It is nothing but continuously compounded returns of share. I will just, let me come on to my Excel sheet. Or one second, guys. Okay, let us say t equal, this is time, this is 0 and 1 is tomorrow. Okay, this is the share price. Today the share price was 180. Tomorrow the share price is 200. Agree? Now if I ask you to calculate the return, what you would basically do is you would do 200 minus 180 divided by 180. Okay, so your return was 11 percentage for 1 day. Agreed? It's 11% effective for 1 day. Alternatively, what you can do is you can do ln of 200 divided by 180. Okay, the answer you get is 10.53, 10.54 percentage. This is also the return, but this is the return on a continuously compounded basis. Okay, it is 10.554 percentage on a continuously compounded basis, whereas 11 percentage return was actually effective return. Okay, if you, I mean, for those of you who know, I'm just showing it to you. Even if you do not, it's fine. Exponential of this number minus 1 will give you 11.11 percentage. Exponential of this number will give you actually 1 plus that return, and that is the reason I'm actually reducing 1 again, because you only need the return component. You don't need the principal plus return, right? Okay, so exponential to the power of 0.1054 is going to give you principal plus return. Since I don't want the principal component, I'm reducing one from it to get the effective return for 1 day. Okay, anyways, this is the relationship between effective return and continuously compounded return. Even if you do not know, it's fine, but just know that ln of xt divided by ln of xt minus 1 is nothing but continuously compounded return for a share. Okay, so ln of xt by xt minus 1 follows normal distribution, meaning that continuously compounded returns follow normal distribution. Okay, this is the second implication, and this implication is actually a little questionable, because in real world probably all returns do not fit into a normal distribution. Okay, a normal distribution basically says that you have a perfect bell-shaped curve, okay, like this, mean equal to median equal to mode, and then you have skewness of 0, because you know it is not, it's not either positively skewed or negatively skewed, and kurtosis is equal to 3. Okay, this is the these are the conditions for normal distribution, right? Mean equal to mode equal to median, skewness is equal to 0, and kurtosis is equal to 3. Okay, in the real world this could be a little questionable, because share returns can probably move a little more randomly and abnormally in such a way that skewness might not be equal to 0, kurtosis might not be equal to 3, and you might actually have fatter tails. Okay, you will have fatter tails. This is not relevant for CA's final syllabus at all, because you have not probably read normal distribution to that fullest extent. I'm talking more to address CFA and FRM students. You could probably have fatter tails, and you could have higher peaks as well, and there could be different possibilities, right? I mean, your skewness might not be, you might be slightly positively or negatively skewed, and so on. Okay, so the second implication is that continuously compounded returns follow normal distribution. So two things, when you're saying that stock prices follow log normal distribution, one thing that you're assuming is that the value x cannot be less than 0, which holds true for share prices. The second implication is that ln of x follows normal distribution. Ln of x following normal distribution means nothing but continuously compounded returns follow normal distribution, and this implication can be questioned, because in real life the share returns not necessarily fit into a normal distribution. Okay, that is what I've written over here in the first and the second point. Okay, the third point is, it also assumes that the share price moves in a smooth manner. Apologies. The share price actually moves in a smooth manner, okay, and it does not exhibit abnormal jumps. Okay, it does not exhibit abnormal jumps. Okay, and this is on account of the geometric Brownian motion. For instance, when I say the share price can move anyway, okay, let us say this is again the graph that we were drawing. The share price is 170 today. What it says is what Black Scholes says is the share price can go as high as up to 290, or it can fall as low as up to 105. I agree. Okay, but that will happen in a smooth fashion. It will basically have no jumps. Okay, this is how the share price will move, is what Black Scholes is assuming. Okay, the share price cannot move. Let me write, the share price cannot basically have these kind of fluctuations to reach this position. It has to move in a good fashion. Of course, there will be increases and decreases, okay, but these are not going to be jumps or abnormal shocks. These are going to move in a smooth fashion. Okay, that is what Black Scholes' assumption is, and this is on account of both log normal property and the geometric Brownian motion. Okay, and therefore we cannot apply Black Scholes model for few stocks which exhibit such abnormal jumps, and for emerging market currencies that also exhibit huge movements. Okay, for example, if a stock is expecting a merger announcement, the stock can go high or it can fall. Okay, in such cases, you're not supposed to use Black Scholes model for valuing options, because the assumption of Black Scholes inbuilt is that the share price moves in a smooth manner without any significant jumps. Okay, that is the last implication of log normal property and geometric Brownian motion. Okay, I think let me just quickly have a look if I've missed out on anything. Okay, I think that is it. I believe this is actually the third time that I'm recording this lecture, because I was trying to make it better and better and better. I hope I've achieved whatever I intended to. Hope I've communicated the logic behind Black Scholes, what Black Scholes is doing under the risk neutral framework. Okay, thank you guys. I hope I don't have to record this lecture once again. I will be having a look at it. Okay, thank you guys. Bye.